So our last part for tonight's lecture is all about aldehydes and ketones. So here I've drawn what the two functional groups for these molecules look like. They're almost identical. The only difference is that in aldehydes, the CO double bond comes at the very end of the molecule. And in ketones, the CO double bond comes in the middle. We call this carbon, the one that has the double bond with the oxygen, the carbonyl carbon. C-A-R-B-O-N-Y-L, carbonyl. That's the carbonyl compound. I'll be using that terminology as I'm going through, so make a note of that. Okay, so let's start with nomenclature. We're going to first identify the longest carbon chain that contains the CO double bond. Then what we'll do is change the ending E, the very last E, to AL. AL is for the AL in aldehyde. We're going to always number our chain so that that carbonyl carbon is always carbon 1. Because in aldehydes that comes at the very end of the molecule. And steps 2 through 5 are the same as they've been before. Okay, so let's do some examples. So we're going to start numbering here. 1, 2, 3, 4, 5. 5 is pentane. And now we're going to take off that last E and put an AL there. Pentanal. Pentanal is how you pronounce that. Okay, now there are substituents, so we have to put those in and alphabetize. It looks like we have 2 methyl groups. So we're going to call this 2,3-dimethyl. Dimethylpentanal. That's that aldehyde. Here's another example. This is a little bit trickier. Always start with your identifying your longest carbon chain. We have 7. That's heptanal. And then now put in your substituents. We have 4 different substituents. We'll start out with 4-ethyl. Then we have 5, 5, 6, trimethyl. Oh, I made it. 4-ethyl 5,5,6 trimethyl heptanal. That's exciting. And now one from your homework. Pay no attention to this. This is number 29. Always start numbering at the 1. And incidentally, this is why we don't have to write 1-butanal, because we're assuming that you're starting to number at that 1. So all aldehydes always start with the CO double bond here at the beginning. Okay, so this is 2-methyl butanal. Now, there are a couple of what are called common names for some of the aldehydes, and that means that they're not using the nomenclature system, but over the years they've developed these common names, sort of like terms in your medical jargon have common names that you know what they are, and everyone just calls them those things. Can't come up with a good analogy off the top of my head. But these are common names. This is formaldehyde. In one of the previous sections, I was talking about how when you have methanol poisoning, your body actually produces, breaks down the methanol and produces formaldehyde, which is toxic to a person. That is what formaldehyde is. It's like a pickling agent. This is acetaldehyde. one to spell. My board is doing that funny thing again. And this is benzaldehyde. And these are just some common names. You don't have to have these memorized, but if you happen to see these names floating about, these are the molecules that are associated with those names. If you were going to name this compound using the nomenclature system, this would be methanal. This is ethanal. And this you don't have to worry about. Okay, so now let's switch gears and talk about nomenclature for ketones. It's basically the same as for aldehydes, except that we're going to switch the ending, the E ending, to O-N-E or own, as opposed to the al for aldehydes. And you'll notice here that this own is the ending of ketone. And we're going to number so that the CO double bond has priority. That means that that should try to have the lowest number possible. And all the other steps are the same. Okay, so let's name this example. Now, if we start from here, we know that we should have a 6-membered ring, but I don't think that's the lowest number. No. So we should start numbering from left to right. Here we're going to have 3-hexanone. And now here again, you have to identify that your ketone is on the 3-carbon. Excuse me. And now we're going by this number here. So that means we have 4-methyl. Be careful here that you're always separating your words and numbers with a dash. So this compound is 4-methyl-3-hexanone. Okay, we can do another one. Looks like we'll have to start from the right this time. So here we would have 2-hexanone. And then we have 2 methyl groups, so that would be 4,5-dimethyl -2-hexanone. Now you guys should be able to do this on your own. This is one from your homework. Can I just do this one? I apologize if this is one I just did. Oh, it's not even that late. Well, now you have the answer for this twice. 4-methyl-3-hexanone. Okay. Okay, so now I just wanted to show you a couple of different interesting aldehydes and ketones. Aldehydes and ketones are usually pretty fragrant, and they occur naturally in a whole bunch of compounds. Here we have a ketone. This is 2-heptanone, so chain of 7, and this is what makes blue cheese smell the way it does. So if you were to isolate just this compound in the lab, it would smell just like blue cheese. Here we have cinnamonaldehyde, which is the cinnamaldehyde, which is the odor of cinnamon. In one of my lab experiments that I do with my organic chemistry students, we get to make cinnamaldehyde, and it's a fun lab because it smells pretty, as opposed to a lot of other organic compounds that smell gross. Here we have citral. This is obviously a common name because this isn't its standardized name. This is the odor that makes lemongrass smell lemony. And here we have benzaldehyde, which gives us the aroma of almonds and cherries. So we have some pretty interesting different examples of how these things are found in nature. And a lot of times they have pretty pungent odors. Oh, if you guys are having questions on any of the naming stuff, I know it's pretty heavy on the naming, go back and watch the part 1 of lecture 5.2. That should help you. Otherwise, post some questions in the discussion forum for this homework, and or email me or call me, and I can help you walk through some of those trickier ones. Good luck.